Hello friends, this video on equilibrium part 31 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Now let's talk about steps to find pH of a weak electrolyte. So I have taken an example of a weak acid and I want to find what is the pH of the weak electrolyte. So let's see how we can do. So we will generally use the Lowry and Bronsted definition of the acid and base. We will not use the Lewis one where we talk about the electron pair transfer. We will talk about the Lowry and the Bronsted acid and base definition where we talk about the proton donor and the proton acceptor. Right? We'll write the balanced possible reactions and we'll write which one is acid and which one is base. Right? The reaction with higher Ka is the primary reaction. Other is secondary reaction. Please note this point. If you have more than one reaction, we'll take some examples of this. You find the value of K for all. The one with the higher K will be the primary reaction. Because to find pH, you need only one reaction, right? You can't have 5 reactions. So the next step is to find the primary reaction if you have more than one reaction. And how you can do it, you can find a K of all the reaction. The one with the maximum value of K is the primary reaction. Right? And we'll put everything in the tabular form. We'll put the initial concentration, the degree of ionization, the equilibrium concentration. Example, initial concentration was C, degree of ionization is alpha, the equilibrium concentration will be C into 1 minus alpha for the products. The reactant will be C alpha and C alpha. We'll take this one example to explain this. So we have written all the concentrations here, and then we'll substitute the value of, we'll create a Ka and we'll put all these values and we'll solve it, we'll get the value of alpha. So we have, if example K will be something like, we have this value, right? K alpha, K was C alpha square by minus alpha, right? So we'll put the value of K, we'll put the value of C, we'll get the value of alpha. We'll solve for alpha, and then once we have the alpha, we have the equilibrium constant for all the species, right? So we'll have equilibrium concentration for all the species. So we'll have equilibrium concentration of H plus also. So just get the minus log of H plus to get the pH. We'll take one example for this. So it says the degree of ionization for HF is 3.2 × 10⁻⁴, and the degree of dissociation for HF is in its 0.02 m solution. We have to find that, and we have to calculate the concentration of all these values and also find the pH. So the reaction is something like this. I have HF, let's react to H3O plus and F minus. You have to add water here. This is my reaction. This is aqueous, this is liquid, this is aqueous, this is liquid. Correct? So this is one reaction. Also, since there is water there, water will also react to form H3O plus and OH plus. So K for this is what? 3.2 into 25 minus. And for this K, W is what? 10 to the power minus 4. Which one is bigger? This guy is bigger. So we'll ignore this reaction. We'll take this reaction. This is my primary reaction, right? So this is my primary reaction. The first part is done. I wrote a balanced equation. I got the primary reaction. So let me write this primary reaction once again here. Just draw a line here. So I have this HF plus H2O gives H3O plus F minus. This is my primary reaction. So at T is equal to 0, I had 0.02 m solution. This was 0. This is not, ignore this is pure liquid. This was 0 and this is 0. At T is equal to equilibrium, this becomes 0.02 into 1 minus alpha. This becomes 0.02 into alpha, and this becomes 0.02 into alpha. Because alpha is, we have to find degree of dissociation. So you want to find K. K is what? 0.02 alpha into 0.02 alpha, right? These two divided by 0.02 into 1 minus alpha. This cancels, and this value is given 3.2 into 10 to the power minus 4. So you solve, you get alpha is nothing but 0.12 and minus 12, minus 0.12. So alpha negative is not possible, ignore this value, alpha is 0.12 and 10. So I have taken alpha as 1 to 0.12, my degree of dissolution is 0.12, so this is my answer. The next one is to find the concentration of H3O plus now. So concentration of H3O plus will be equal to concentration of F minus, both will be same, and both will be equal to C alpha, that is 0.02 into alpha, alpha is 0.12. If you solve this, you get 2.4 into 10 to the power minus 3. Concentration of HF will be what? 0.02 into 1 minus alpha. 1 minus alpha, that is 0.12. So you solve this, you get 1.76 into 10 to the power minus 3. This part is also done. Now you need to find the pH. pH is nothing but, so pH is nothing but minus log of H plus ion concentration. Minus log of, what is the value of H plus ion concentration? 2.4 into 10 to the power minus 3. Right? So we solve this, you get 2.62 as my pH, and that is my answer. So let's take one more question. Here the pH is given, the initial concentration is given. We have to find the concentrations of the species that are given. Example, the reaction is we have HA acid, it gives HA plus and A minus. T is equal to 0, this was 0.1 m, this was nothing. At T is equal to equilibrium, the pH is minus 4. This is, let's suppose, minus 1 minus x, this becomes x and this is x, right? So you need to find the value of x first. So x is nothing but what? H plus ion concentration, and that is nothing but minus log of, that is nothing but, I can find the H plus ion concentration. How? pH is given, pH is equal to 4.5. So if the pH is 4.5, you can find H plus concentration, that comes out to be 3.16 into 10 to the power minus 5. How? pH is equal to 4.5, that is minus log of H plus ion is 4.5. So you solve this, you get H plus, log of H plus is minus 4.5, that is 5 bar 0.5, and H plus is nothing but anti-log of this, and that is nothing but 3.16 into 10 to the power minus 5. So I got the H plus ion concentration. This is nothing but 3.16 into 10 to the power minus 5. Also we know that A minus ion concentration is also same. So my A minus ion is also equal to this value. So what is the value of HA concentration? That is 0.1 minus x. This 0.1 minus x we have got 3.6 into 10 to the power minus 3.16. This is almost equal to 0.1 only. So to find Ka, K is what? K is my H plus ion concentration into A minus ion concentration divided by HA concentration, right? Simple formula we have. So let's put the values. This becomes 3.16 into minus 5 into 3.16 minus 5 by 0.1. So if you solve this, you get 1 into 10 to the power minus 8. That is my Ka. K is found. I define pK also. pK is what? pK is nothing but minus log of K. That is what? Minus log of 10 to the power minus 8. If you solve this, you get 8. So pKa is 8. We'll take one more example. So we have to find the pH of a 0.08 m solution of a hypochlorous acid where the ionization constant is given. The reaction goes like this. We have HOCl in the aqueous. Put some water here, this is a liquid. It becomes H3O plus and ClO minus aqueous. Right? Now, at T is equal to 0, it is told that is 0.08 m solution is 0.08. This is not required. This is 0 and this is 0. At T is equal to equilibrium, let's suppose this becomes 0.08 minus X. This becomes x, this becomes x. So to find H3O plus, you can find easily, I can find KL, Ka. Ka is what? X square by 0.08 minus x. That is concentration of H3O plus into concentration of Cl minus by concentration of H2L, HCl, because H2O is ignored. And this is given 2.5 into 10 to the power minus. Correct. So with this, if you solve, the value of x comes out to be 1.41 minus. This is nothing but my H plus ion concentration. So my pH is what? Minus log of H plus ion concentration, that is this guy, 1.41 into the power minus 3. You solve this, you get 2.85 as the pH. And that is my answer. Done. Second is you define percent dissociation of HCl. So percent dissociation is what? This guy, x by 0.08 minus 6. See, that is percent dissociation is nothing but percentage of HCl dissociated. This is x by, sorry, the number of HO plus ion dissociated by the number of HCl undissociated. So this will be x by 0.08 minus x into 100, because I'm looking for percentage. So you solve this, you get 1.76%. Put the value of x, you get 1.76%. That is that. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.